the space object that entered our solar system and was never seen again. The night the solar system was violated. For billions of years, nothing from another star system had ever been observed entering our solar system. Planets followed predictable paths, asteroids and comets remained bound to the sun, and the night sky appeared stable to those who studied it. Then, in October 2017, that sense of order was broken. A faint, fast-moving point of light appeared unexpectedly in the vastness of space. It was first detected by Pan-STARRS-1, a powerful telescope in Hawaii designed to scan the sky for near-Earth objects. At first glance, it looked ordinary, just another asteroid or comet. But as astronomers analyzed its motion, something became clear. This object was not behaving like anything they had ever seen before. Unlike familiar bodies trapped by the sun's gravity, this visitor was moving too fast. Its trajectory was strange and its path unmistakable. It was not looping around the sun. It was passing through on a course that would carry it out of the solar system entirely. This was no local wanderer. Its brightness fluctuated dramatically, suggesting an unusual shape, possibly long and elongated, unlike typical asteroids. Its speed hinted at an origin far beyond our sun's reach, a journey that may have taken millions of years across interstellar space. For astronomers, excitement turned into urgency. This was a once-in-a-lifetime opportunity to observe something truly alien in nature. Across observatories worldwide, scientists scrambled to confirm the data. Some suspected instrument errors, others questioned the calculations, but the numbers refused to change. The object's orbit was hyperbolic, meaning it was not gravitationally bound to the sun. It had come from another star system. As telescopes tracked it night after night, the scale of the discovery began to sink in. The object was small and faint, easily missed without constant sky surveys, yet it carried profound implications. It offered a glimpse into how planetary systems form elsewhere in the galaxy, how material moves between stars, and how often interstellar visitors pass silently through our cosmic neighborhood. To the public, it remained invisible to the naked eye, but to scientists, it was undeniable. This was the first confirmed interstellar object ever detected moving through our solar system. And almost as quickly as it had appeared, it began to leave, slipping back into the darkness between the stars. It left behind no physical trace, only fading light and a cascade of questions that science is still struggling to answer. A routine scan turns into panic. Astronomers are accustomed to surprises, but most are small, routine, and ultimately explainable. Observatories routinely scan the skies for asteroids that might threat Earth or comets that could offer clues about the early solar system. Yet when Pan-STARRS flagged the new object, something about its trajectory immediately raised concern. Its motion didn't resemble the slow, predictable arcs of standard asteroids. It was faster, its path was sharper, its brightness changed unpredictably. As teams across the globe examined the data, the reality sank in. This object was leaving the solar system. It wasn't orbiting the sun in a familiar ellipse. It was passing through, making a one-way journey back into interstellar space. Astronomers, who often see unusual data points dismissed as anomalies or instrument errors, found themselves in a rare situation where every measurement aligned to something completely unexpected. The excitement was tinged with pressure. Observatories in Chile, the Canary Islands, and Australia were mobilized to track it. Each additional measurement refined its orbit, confirming that it had come from beyond our solar system. The calculations were painstaking, the nights long, and the stakes high. Every moment mattered because the object would soon fade from view, disappearing before it could reveal all of its secrets. Even more extraordinary was its velocity. Ordinary objects in the solar system follow paths dictated primarily by the sun's gravity. This interstellar visitor moved in a hyperbolic orbit, meaning it had enough speed to escape the sun's pull entirely. No one had ever seen such an object enter the solar system and leave again. Its very existence suggested that planets and stars exchange matter across the galaxy far more frequently than anyone had imagined. For the astronomers involved, the discovery was thrilling but sobering. Humanity had a fleeting chance to study an object from another star system, perhaps a glimpse of what materials, shapes, and forces exist beyond our solar neighborhood. And yet the window to act was closing. Within weeks, the visitor would be gone, leaving behind only faint traces in telescopic images, a mystery that would ignite scientific debate and capture imaginations worldwide. The first impossible measurement. The defining clue that this was no ordinary object came from detailed measurements of its trajectory and brightness. As the observations accumulated, astronomers noted that the object's speed and hyperbolic path left no doubt. It originated from outside the solar system. Unlike asteroids, which orbit the sun predictably, this object was passing through on a path shaped by forces beyond our immediate knowledge. Eventually, it would be named Oumuamua, meaning scout or messenger in Hawaiian, a name that captured its fleeting and mysterious nature. Yet even with the initial excitement, a puzzling detail emerged. Its velocity appeared to change slightly in ways that could not be explained by gravity alone. Normally, comets experience small accelerations as sunlight heats their surfaces, releasing gases in a visible tail. But Oumuamua showed no such tail or cometary activity. There was no visible outgassing, no hint of the mechanisms that could account for its subtle acceleration. Scientists were forced to confront a profound uncertainty. Here was an object behaving unlike anything they had ever studied, obeying some rules of physics while seemingly breaking others. Adding to the intrigue, its brightness varied dramatically as it tumbled through space. This indicated an elongated, possibly cigar-like shape, far more extreme than any asteroid known in our solar system. Its chaotic rotation suggested it had been spinning for millennia, possibly shaped by forces entirely alien to our understanding. The discovery forced astronomers to reconsider long-held assumptions. Our solar system, long treated as a nearly closed system, was in fact a small intersection point in a galaxy filled with travelers. Each passing interstellar object carried with it clues about the processes shaping distant star systems, the prevalence of unusual shapes and compositions, and the limits of our current models. Time was fleeting. Oumuamua was already receding from the sun and Earth, fading rapidly into the cosmic darkness. Observatories had a few short weeks to gather every possible measurement before it became unreachable. In that brief period, scientists documented its speed, trajectory, rotation, and shape, creating a data set that would drive debates, publications, and speculation for years to come. Humanity had glimpsed a messenger from another star system, and its secrets would leave us questioning how much we truly know about the universe. The moment scientists said it's not from here. When Oumuamua's hyperbolic orbit was confirmed, the announcement rippled through the scientific community. For the first time, humanity had clear evidence of an object that originated beyond the solar system, a visitor not bound by the sun's gravity, moving on a trajectory that would carry it forever away. The realization was both thrilling and unsettling. Astronomers meticulously analyzed every frame of data, verifying position, velocity, and brightness. The numbers consistently defied expectations. Every orbital calculation indicated an origin in interstellar space. Unlike long-period comets, which can be traced to the Oort cloud at the edge of the solar system, Oumuamua's path could not be connected to any known source. Its velocity, calculated at approximately 315,000 kilometers per hour relative to the Sun, exceeded the escape speed at its location, confirming it was merely passing through, not captured. International teams mobilized to track it. Observatories in multiple continents joined forces to gather every possible measurement. The scramble was urgent. The object was small, faint, and moving fast. Even with the world's most powerful telescopes, it was quickly fading from view. Scientists had a tiny observational window to document something that would leave the solar system forever. Researchers began to consider what Oumuamua might be. Its elongated shape, inferred from variations in brightness, was unlike any asteroid previously catalogued. It was estimated to be hundreds of meters long, perhaps cigar-shaped, with chaotic tumbling motion. Standard solar system physics could not fully explain its trajectory or acceleration. Even at this early stage, it was clear that Oumuamua represented a challenge to conventional astronomical models, a puzzle with no easy solution. As news spread through scientific journals, conferences, and online platforms, discussions became heated yet careful. Astronomers were aware of the temptation to sensationalize, but the evidence demanded acknowledgement. The solar system was not as isolated as once assumed. Objects could arrive from interstellar space, carrying with them shapes, compositions, and behaviors never before observed. For the first time, humanity was witnessing an encounter with the cosmic unknown. The significance extended beyond novelty. Oumuamua's discovery suggested that other interstellar objects likely passed through our solar system undetected, silently traveling through the void. The implications were profound. The galaxy may be full of small alien travelers, each a messenger from distant stars. Humanity had a fleeting chance to observe one, and for scientists, the race against time was on to uncover as much information as possible before the visitor disappeared forever. Speed that defied expectation. One of the most astonishing aspects of Oumuamua was its speed. Calculations revealed that it was moving at approximately 315,000 kilometers per hour relative to the Sun, faster than any other object ever observed entering the solar system. Its trajectory was hyperbolic, meaning it possessed enough kinetic energy to escape the sun's gravitational pull entirely. This alone marked it as unique, but further scrutiny revealed a subtle anomaly. It was accelerating slightly as it moved away from the sun. Ordinarily, comets exhibit such acceleration because sunlight heats volatile ices on their surfaces, causing jets of gas that act like thrusters. These jets produce visible tails or comas, which are easy to observe. Oumuamua, however, displayed no tail. Telescopes detected no gas, no dust, nothing that could explain the acceleration in conventional terms. It moved as if pushed by an invisible force, a phenomenon that left astronomers both puzzled and fascinated. To understand its motion, scientists combined data from multiple observatories, using precise astrometry to trace every fraction of its path. Its speed varied subtly in ways that contradicted simple gravitational models. While tiny variations in trajectory are normal for solar system comets, Oumuamua's movement suggested a force beyond standard cometary activity, yet no emissions were observed. Even more intriguing was its passage through the inner solar system. It made its closest approach to the Sun at 0.25 astronomical units, roughly a quarter of the distance between Earth and the Sun. At such proximity, any volatile material would likely sublimate, producing detectable signs of cometary activity, yet nothing was observed. Scientists were forced to acknowledge that Oumuamua defied known categories. It was neither a typical asteroid nor a conventional comet. The mystery of its acceleration ignited debates in the astrophysical community. Was this evidence of an unknown natural process? Could it be a fragment of an exoplanetary system shaped by forces unfamiliar to us? Or did it hint at something entirely unexpected, a structure unlike anything cataloged in our solar system? Observers knew the object would soon vanish into the darkness of interstellar space, taking its secrets with it. In that fleeting moment, humanity glimpsed something extraordinary, an interstellar traveler that challenged assumptions, accelerated beyond expectations, and vanished before our eyes could fully comprehend it. No tail, no coma, no explanation. As Oumuamua sped through the inner solar system, astronomers searched for the classic signs that would identify it. Comets release gas and dust when warmed by the sun, creating a visible tail or coma. Asteroids, on the other hand, are rocky and inert, following predictable paths, yet Oumuamua defied both categories. Telescopes scanning for emissions detected nothing. No tail, no gas, no dust, only a streak of light moving against the background of stars. This absence of visible activity made its slight acceleration even more perplexing. Non-gravitational forces were clearly at work, but without a tail or coma, the source remained unknown. Scientists considered every possibility. Could it be a fragment of an exoplanetary system? Could solar radiation itself or an unknown outgassing process be producing the observed motion? Each hypothesis faced challenges, but none fully accounted for the observations. The object's brightness also offered clues. Oumuamua exhibited significant variations over time, suggesting an extreme elongation. Estimates suggested it could be 10 times longer than it was wide, unlike any asteroid or comet in the solar system. It tumbled chaotically, spinning irregularly as it traveled at incredible speeds. This combination of unusual shape, rotation, and acceleration made Oumuamua a scientific enigma, forcing astronomers to confront a rare moment in the history of observation: the encounter with a truly alien object. Observatories worldwide raced to capture every possible measurement before the object faded. Within weeks, its brightness would drop below the detection limits of even the most powerful instruments. The time to study it was short, and every observation mattered. Papers and preprints began circulating almost immediately, as scientists attempted to model its trajectory, acceleration, and composition with incomplete data. Each model offered partial insights, but no single explanation satisfied all the observations. Oumuamua's passage left the scientific community in awe and speculation. It was a reminder that the universe is full of surprises, that even in the well-studied solar system, phenomena can appear that challenge assumptions, defy classification, and spark debates. For a brief period, humanity had observed a traveler from another star system. It arrived, passed silently, and left, carrying its secrets into the infinite reaches of space. No tail, no gas, no definitive explanation, only a lingering question. What else might be silently passing through, unnoticed, just beyond our gaze? A shape never seen before. As data poured in from telescopes across the globe, astronomers began to piece together the object's physical properties. One observation stood out above all others: the extreme elongation of Oumuamua. Unlike any asteroid or comet previously cataloged, its brightness varied dramatically over short periods of time. By analyzing these fluctuations, scientists inferred its shape: long, narrow, and possibly 10 times longer than it was wide. This was unprecedented. Within our solar system, most asteroids and comets are roughly spherical or irregular but relatively compact. The extreme elongation suggested that Oumuamua had been shaped by forces unlike those acting on typical solar system bodies. Perhaps it was a fragment from a violent collision in another star system, a shard of a larger object ejected across light years. Its proportions were so unusual that even experienced astronomers paused to question whether their interpretations were correct. The rotation of the object added another layer of intrigue. Oumuamua did not spin smoothly along a single axis. Instead, it tumbled chaotically, turning over irregularly as it traveled at incredible speed through the solar system. This tumbling motion made its brightness fluctuate even more dramatically, complicating efforts to estimate its exact size and shape. Every observation required sophisticated modeling to account for its irregular rotation. Despite the mystery, the object's visual data allowed astronomers to make confident inferences. The variations in light intensity were consistent with an elongated cigar-like form, though some models suggested a flattened pancake-like shape. Regardless of the exact geometry, it was unlike anything cataloged in our solar system, signaling the arrival of a truly alien object. Scientists debated the implications. Such an extreme shape could not have been formed in isolation. It likely experienced intense processes, perhaps collisions, tidal forces, or ejections from a planetary system far beyond the Sun's influence. The discovery challenged assumptions about the diversity of objects in space, revealing that other star systems could produce structures that defy everything we have encountered. Every telescope observation, every calculation reinforced the same conclusion. Oumuamua was not only interstellar but physically exceptional. It arrived as a fleeting messenger, revealing a form never before seen, spinning unpredictably, and hinting at the variety of objects traveling silently between the stars. Humanity had caught a glimpse of the unimaginable, a shape that defied classification and stretched the boundaries of our understanding. Tumbling through space. Observing Oumuamua's tumbling motion revealed yet another layer of mystery. Unlike most solar system bodies, which spin steadily along a single axis, this object rotated irregularly, twisting and flipping unpredictably as it passed through the inner solar system. The chaotic tumbling indicated that it had experienced significant forces during its history, possibly collisions or ejections from its home system, leaving it spinning without a stable rotation. Astronomers analyzed the changing light intensity as Oumuamua rotated. The variations were dramatic, sometimes shifting by a factor of 10 in brightness over a single rotation period. These measurements allowed scientists to model its spin and shape simultaneously, revealing that the object was elongated, tumbling, and irregular in ways inconsistent with standard asteroids. Each rotation presented a new puzzle. How could a natural object maintain such a shape while surviving interstellar travel? The tumbling motion also complicated attempts to determine its density and composition. Small variations in speed suggested that non-gravitational forces might be acting on it, but there was no visible outgassing to explain the acceleration. Scientists considered whether radiation pressure from sunlight could contribute, though this would require assumptions about its surface properties and reflectivity that are difficult to confirm from Earth-based observations. Despite the complexities, the tumbling revealed a cosmic truth. Oumuamua was not a simple, inert rock. It was a dynamic spinning fragment of interstellar material, a traveler shaped by forces that may have included close stellar encounters, collisions, or ejections from planetary systems. Its chaotic rotation made it impossible to fully predict its behavior, yet every measurement reinforced its alien nature. Public fascination grew as astronomers shared the findings. The unusual shape and tumbling motion sparked discussions not only in scientific journals but across popular media. People imagined what forces in distant star systems could create such an object, how many others might pass through the galaxy unnoticed, and whether humanity would ever encounter another visitor like it. Oumuamua's tumbling motion would remain one of its defining features. It was a physical signature of its interstellar origin, a clue that this was not just another asteroid, but a messenger shaped by forces beyond our immediate understanding. As it sped away, tumbling ever faster into the void, it left observers with the humbling realization that the galaxy is filled with objects of unimaginable variety, silently passing through the space between stars. The name that meant messenger. After the initial observations confirmed its interstellar trajectory, the object was formally designated 1/Oumuamua. The name in Hawaiian means scout or messenger, reflecting its status as the first known visitor from another star system. The designation honored both its origin and the observatory that first detected it, highlighting humanity's role in witnessing a phenomenon that had traversed light years to briefly enter our solar system. The name carried profound significance. Oumuamua was a literal messenger from the stars, arriving without warning, passing through without pause, and leaving only a trail of data and questions. For astronomers, the name underscored the fleeting nature of the encounter. Observations were limited to a few weeks before it became too faint to track, emphasizing the rarity and urgency of studying such objects. Beyond its trajectory and motion, the name encapsulated the mystery of its nature. Was it a fragment of a larger body, a piece of a distant planetary system's debris, or something even more unusual? Scientists debated the possibilities in technical papers, conferences, and media interviews, but no definitive explanation emerged. The name Oumuamua reminded everyone that this was an object with a story, a visitor carrying the imprint of processes far beyond the reach of our solar system. The symbolism of messenger also sparked public imagination. People speculated about its origin, its purpose, and whether it might be the first of many such interstellar travelers. While scientists cautioned against jumping to sensational conclusions, the name itself invited curiosity. It was a reminder that the universe is not static, that matter can traverse unimaginable distances, and that humanity is only just beginning to observe these rare phenomena. In the days and weeks following its discovery, Oumuamua became the subject of intense study and discussion. Its elongated shape, tumbling motion, unusual acceleration, and interstellar origin combined to make it one of the most extraordinary astronomical objects ever observed. The name reinforced its uniqueness, a messenger arriving silently, departing quickly, and leaving the world to wonder what secrets it carried. Even as it disappeared into the void, fading from view, Oumuamua's legacy was established. It had opened a new chapter in astronomy, one that emphasized the universe's unpredictability and the potential for discoveries that challenge assumptions. For scientists and the public alike, Oumuamua would remain a symbol of the unknown, a reminder that sometimes the cosmos sends messages in forms we are only just beginning to understand. Scientists realized they are running out of time. As Oumuamua sped away from the sun, the clock for meaningful observation began ticking rapidly. Within days, its brightness was fading, dropping steadily toward the limits of even the most powerful telescopes. The object that had initially appeared as a faint point of light was now a vanishing visitor, retreating toward interstellar space at an incredible speed. Scientists knew they had only weeks, perhaps even days, to gather every possible piece of data. Observatories worldwide coordinated their efforts. Hawaii, Chile, the Canary Islands, and Australia focused their most sensitive instruments on the object, capturing high-resolution images, light curves, and spectral data. Teams of astronomers worked tirelessly, often through the night, to schedule observations across multiple facilities. Every hour mattered. Every missed measurement represented an opportunity lost forever. The urgency wasn't just academic. Oumuamua offered the first chance in recorded history to study a body from another star system. Its trajectory, shape, and acceleration could reveal insights about planetary formation in distant solar systems, the physical limits of objects traveling through interstellar space, and potentially even new processes that have never been observed in our own system. To let it escape unstudied would be an irreplaceable loss. Despite their efforts, astronomers faced limitations. Oumuamua was small, likely only a few hundred meters long, and extremely faint. Its fast movement meant tracking it accurately required precise timing and coordination. Clouds, atmospheric turbulence, and instrument availability all threatened to limit the quality of the data. Scientists described the effort as a cosmic sprint, chasing a visitor that would not wait for humanity to catch up. Even with all this urgency, the team remained disciplined. Sensationalism was avoided. Every measurement was verified and cross-checked. Multiple models of its orbit, shape, and acceleration were calculated to ensure accuracy. Yet there was an underlying tension. No matter how sophisticated the instruments, no matter how fast the analysis, Oumuamua was on a one-way journey, destined to leave the solar system. Every second that passed brought it closer to the edge of detectability, and every second increased the possibility that some secrets would never be known. In laboratories and observatories, researchers grappled with a mixture of awe and frustration. Here was a messenger from another star system, arriving unannounced, revealing phenomena never before observed, and slipping away before the world could fully understand it. Humanity had been granted a fleeting glimpse of the interstellar unknown, and the realization weighed heavily. The data we collected would be precious but incomplete. The missed opportunity. The limitations of human technology became painfully clear as Oumuamua continued its rapid departure. While telescopes could track it and gather light curves, no spacecraft could reach it. Even the fastest probes humanity had ever launched would have required decades to intercept the object, by which time it would be far beyond reach. This realization sparked both admiration and frustration within the scientific community. Humanity could witness such an extraordinary visitor, but we could not touch it, study it directly, or fully unravel its mysteries. Astronomers compiled every observation possible, creating a dataset that included its position, brightness, rotation, and acceleration. Yet the questions remained. How had it been shaped? What was its composition? Did it contain materials from a distant star system that might expand our understanding of planetary formation or the evolution of interstellar matter? These answers would remain elusive because the observational window was too short. Even indirect methods, such as spectroscopy, yielded only limited information. Oumuamua was faint, and its surface reflected little light. Observers could estimate its composition in broad terms, likely rocky with unusual surface properties, but definitive chemical analysis was impossible from Earth. Every effort to probe further was constrained by physics and distance, highlighting the harsh reality of studying fast-moving interstellar objects. Scientists also faced a race against time in data analysis. Measurements had to be calibrated, light curves interpreted, and models tested. Errors could not be tolerated because there would be no opportunity for reobservation. Every calculation became a snapshot frozen in time, representing humanity's brief encounter with a celestial visitor that would vanish forever. The missed opportunity was a source of reflection as well as frustration. Oumuamua had arrived unexpectedly, giving humanity only a narrow chance to observe an object from beyond the solar system. It highlighted both the limits of current technology and the vastness of the galaxy, reminding astronomers that interstellar travelers may pass unnoticed every day. The object's brief visit underscored the need for faster detection systems and rapid response missions, lessons that could guide future efforts to study interstellar objects more effectively. In the end, Oumuamua became a symbol of both human curiosity and limitation. We could track it, measure it, and marvel at it, but we could not interact with it. We could only observe, analyze, and speculate. Its fleeting journey left us with knowledge, yes, but also a haunting sense of incompleteness. It was a visitor from the stars, gone almost as soon as it arrived, leaving behind more questions than answers and inspiring a generation to look to the skies in search of the next messenger. The last clear image. In the final weeks before Oumuamua became undetectable, observatories captured the last clear images of the object. Even through the most powerful telescopes, it appeared as a faint streak, a tiny point of light against the infinite darkness. Each photograph, each data point was carefully cataloged and analyzed, representing humanity's last chance to document an interstellar visitor. These final observations were critical. By measuring the light curve, astronomers could continue to infer its shape and rotation. Even as the brightness faded, the variations in light confirmed extreme elongation and tumbling behavior. No matter how faint it became, Oumuamua continued to provide clues about its physical characteristics, each observation adding layers to the mystery. Spectral analysis of the last images revealed little, but enough to suggest that its surface was dark, reflecting sunlight poorly similar in some ways to organic-rich asteroids in our own solar system. However, the exact composition remained a mystery. The subtle acceleration persisted, unaccompanied by any detectable tail or gas emissions. Each measurement confirmed that Oumuamua was unlike anything studied before. As the object receded, astronomers felt a sense of both closure and loss. The final images marked the end of active observation. Oumuamua would continue its journey through interstellar space, never to return, carrying with it all the secrets of its origin and history. The fleeting encounter had provided groundbreaking data, but many questions remained unanswered. In the scientific community, the last images fueled papers, debates, and models. Every team sought to make sense of the data, to explain the non-gravitational acceleration, the extreme shape, and the chaotic rotation. Hypotheses were proposed, refined, and challenged, but certainty remained out of reach. The object had departed, leaving behind a dataset that would be studied for years and remembered as a rare glimpse of the unknown. For the world watching, Oumuamua's departure reinforced a profound realization. The galaxy is alive with travelers, moving silently between stars, some perhaps on trajectories that will bring them near Earth only once in countless millennia. Humanity had witnessed one such visitor, fleeting and enigmatic, captured in images that now stand as the last clear record of its journey. It was a reminder of the vastness of the cosmos, the limitations of human observation, and the enduring mystery of what lies beyond our solar system. As Oumuamua receded from the solar system, the world of astronomy erupted with speculation. Scientists, faced with its extraordinary trajectory, extreme shape, and subtle acceleration, began proposing theories to explain its behavior. Each theory sought to reconcile the data with known physical processes, but no single explanation fit perfectly. The most conventional hypothesis suggested that Oumuamua was a cometary fragment. Comets often accelerate slightly as sunlight heats volatile ices on their surfaces, creating jets of gas that act like natural thrusters. But unlike any comet ever observed, Oumuamua showed no visible tail or gas emissions. Its acceleration appeared real, yet the expected signs of outgassing were absent. This discrepancy sparked debate about whether unknown types of volatile materials might exist that could sublimate without leaving detectable evidence. Other scientists suggested a rocky, asteroid-like origin. Perhaps it was a fragment ejected from a planetary system after a catastrophic collision, a shard that had traveled light years through the galaxy. This could account for its unusual shape and tumbling motion, yet it did not explain the subtle acceleration observed. For some researchers, this inconsistency hinted at processes not yet understood in interstellar dynamics. A more radical idea emerged from Harvard astrophysicist Avi Loeb, who proposed that Oumuamua could be artificial, perhaps a thin, light-reflective structure, like a probe or spacecraft from an advanced civilization. While controversial, the hypothesis gained attention because it offered a plausible explanation for its unusual acceleration without cometary activity. Loeb emphasized that the proposal did not claim proof of alien origin, but rather highlighted that Oumuamua's properties were extraordinary enough to warrant consideration of all possibilities. Other researchers explored exotic natural explanations. Could it be a hydrogen iceberg evaporating in a way undetectable by telescopes? Could radiation pressure from sunlight alone account for its acceleration? Each model faced challenges when applied to the data, underscoring the object's strangeness. Scientific journals filled with preprints and papers as researchers debated the evidence. Conferences featured heated discussions, yet all participants agreed on one point: Oumuamua was unprecedented. Its combination of interstellar origin, extreme elongation, tumbling rotation, and unexplained acceleration was unlike any object previously studied. The debates reflected both the limits of human knowledge and the excitement of encountering a phenomenon that challenged existing models. In the end, Oumuamua's passage sparked a paradigm shift. It reminded astronomers that the universe contains objects beyond our expectations, that interstellar visitors are possible, and that each new observation could challenge assumptions. While the data was finite, the scientific debate it inspired would endure, pushing the boundaries of how humanity understands the cosmos. The debate intensifies. In the months following Oumuamua's departure, the scientific debate intensified. Observatories had collected a wealth of light curves, orbital data, and rotational models, but the object's unusual characteristics left many questions unresolved. Every new analysis seemed to raise more possibilities than answers, prompting spirited discussions in papers, conferences, and media outlets. One of the central points of contention was the object's acceleration. Some scientists argued it could be explained by natural processes, such as outgassing from volatile substances undetectable by existing instruments. Others highlighted that its lack of a visible coma or tail made these explanations less likely. Detailed modeling of its trajectory suggested that even subtle forces, acting over millions of kilometers, could produce the observed deviations from a purely gravitational path. Yet the exact mechanism remained unknown. The unusual shape fueled further debate. Oumuamua's elongation, possibly 10 times longer than it was wide, was unlike any asteroid or comet cataloged in our solar system. Some researchers suggested it could be a fragment from a larger body, shaped by collisions or tidal forces. Others explored the possibility that its geometry had been altered by extreme interstellar conditions, including radiation, cosmic winds, or encounters with distant stars. Each explanation offered insight, but failed to fully account for the combination of properties observed. The controversy reached public attention when some researchers speculated about its potential artificial origin. While most scientists treated this idea cautiously, it ignited broader discussion about interstellar exploration, alien probes, and humanity's readiness to detect non-natural objects. Even skeptics admitted that Oumuamua's characteristics, shape, acceleration, and rotation were extraordinary enough to consider unconventional hypotheses, if only for the sake of thorough investigation. The debate highlighted a key lesson. Humanity's understanding of interstellar phenomena is limited by observation, technology, and imagination. Oumuamua forced astronomers to ask questions they had never considered and to explore models that were once purely theoretical. It reminded scientists that the universe is far more diverse and unpredictable than textbooks suggest. Ultimately, the debate reflected both caution and curiosity. No consensus emerged, but every paper, model, and discussion expanded our knowledge. Oumuamua had departed, but the questions it raised continued to orbit the scientific community, inspiring new research, prompting technological proposals for intercept missions, and ensuring that its brief visit would have a lasting impact on how humanity studies the cosmos. A cosmic riddle. Oumuamua's passage left humanity with a riddle unlike any other. It was a messenger from another star system, fleeting and enigmatic, revealing glimpses of phenomena that challenged existing models while leaving essential questions unanswered. Its origin, composition, and the forces shaping its motion remained uncertain, making it a topic of enduring fascination and scientific inquiry. The object's combination of properties, extreme elongation, chaotic tumbling, subtle acceleration, and lack of a cometary tail was unparalleled. Every model, from conventional cometary physics to the more speculative hypotheses, accounted for some aspects but never the full set. Oumuamua's journey forced scientists to confront the limits of current understanding, highlighting the gap between observation and explanation. This cosmic riddle had practical consequences as well. It demonstrated the need for rapid response observation networks capable of detecting and tracking interstellar objects immediately upon discovery. Oumuamua's brief window of visibility underscored that future encounters might provide more opportunities if humanity can respond faster, deploy more advanced instruments, or even launch intercept missions. Beyond science, Oumuamua captured the imagination of the public. Its journey inspired curiosity about the galaxy, about the objects silently traveling between stars, and about humanity's place in a vast and dynamic universe. It was a tangible reminder that even in the familiar confines of our solar system, the cosmos can deliver surprises that challenge assumptions and spark wonder. For researchers, the object became a symbol of scientific humility. No matter how advanced our instruments or models, there are phenomena that defy explanation, that arrive unexpectedly, and that leave before answers can be found. Oumuamua was a messenger that spoke in silence, challenging scientists to listen closely, analyze carefully, and embrace uncertainty. Its legacy is enduring. As the first interstellar object detected passing through our solar system, it opened a new field of study, ignited debates, and inspired technological proposals for future exploration. And though it will never return, Oumuamua's brief visit will continue to shape scientific thinking, fueling both research and imagination for generations. Humanity had glimpsed a traveler from another star system, and the universe would never seem quite the same again. A glimpse beyond our solar system. Oumuamua's fleeting passage offered humanity its first tangible glimpse beyond the confines of our solar system. For centuries, astronomers had observed distant stars, planets, and galaxies, but nothing had ever arrived from another star system itself. This was not light or radiation. It was matter, a traveler shaped and ejected by forces far beyond Earth's reach, carrying with it the history of a distant planetary system. The discovery reshaped our understanding of the galaxy's dynamism. Objects like Oumuamua are likely common, silently traversing interstellar space. Yet this one happened to intersect with our solar system at the exact moment astronomers had the tools to detect it. Its journey revealed that stars do not exist in isolation. Material can escape one system and travel light years, potentially delivering clues about the diversity of planetary systems, the types of objects that form elsewhere, and the processes that shape them. Scientists began imagining new missions. How could humanity intercept such interstellar visitors in the future? Oumuamua's extreme speed and trajectory highlighted the technological challenges. Any intercept would require rapid response, advanced propulsion, and precise tracking. Yet the prospect sparked a sense of urgency and ambition. If humanity could reach a future interstellar object, it could analyze its composition directly, gaining unprecedented insights into distant planetary systems without leaving the solar system. The object also prompted reflection on what it means to be an interstellar species. Until now, humanity had sent only electromagnetic signals and robotic probes into space, none capable of traveling beyond the sun's influence. Oumuamua's arrival suggested that interstellar material is already moving through the galaxy, connecting star systems in ways previously unimagined. If we hope to explore beyond our own neighborhood, we must learn from these natural messengers, using their trajectories and behaviors to guide future exploration strategies. The discovery also raised philosophical questions. Oumuamua was a visitor with no intentions and no consciousness, yet it challenged humanity's perception of our place in the universe. It reminded us that the galaxy is not static or isolated, but a vast, interconnected web of matter and energy. For scientists and the public alike, the object symbolized the possibility of discovering more interstellar travelers and perhaps one day using them as guides for exploration or as laboratories of alien materials. By passing through unnoticed by human eyes until that fateful October night, Oumuamua had rewritten the rules of interstellar observation. It demonstrated that the galaxy is teeming with objects that, if detected, could revolutionize our understanding of planetary formation, cosmic history, and the practical possibilities for exploration. Humanity's first glimpse of such an interstellar visitor would shape both scientific inquiry and imagination for decades to come. Technology meets the unknown. Oumuamua's passage also served as a stark reminder of humanity's technological limitations. Observatories could track and measure the object, but no spacecraft existed fast enough to intercept it. Even the fastest probes ever launched, such as Voyager or New Horizons, would take decades or centuries to reach it. This reality forced scientists to rethink the requirements for future interstellar exploration. Engineers and physicists began proposing rapid response missions, envisioning spacecraft capable of near-light speed travel, or advanced propulsion systems like solar sails or ion engines. Oumuamua's high velocity and unpredictable rotation demonstrated the challenges of rendezvous and measurement. To study future interstellar objects, humanity would need sensors capable of instant data collection and communication systems that could relay findings across vast distances. The discovery also emphasized the importance of global coordination. Oumuamua was tracked by telescopes on multiple continents, all working in near real time to compile data. Without this collaborative effort, crucial observations would have been lost. The event highlighted the value of international networks of observatories and the potential for coordinated rapid response missions to maximize scientific yield from fleeting interstellar encounters. The subtle acceleration observed in Oumuamua prompted additional technological considerations. If future interstellar objects exhibit similar deviations, spacecraft navigation and tracking would require adaptive systems capable of responding to unexpected motion. Autonomous spacecraft, equipped with AI-guided instruments, could become essential tools in studying these elusive visitors. Moreover, Oumuamua inspired the imagination of private space ventures. The prospect of intercepting interstellar material opened the door to new scientific, commercial, and exploratory opportunities. Companies and agencies began contemplating probes that could chase future visitors, analyze their composition, and return data in real time, creating unprecedented opportunities for discovery without leaving the solar system. Finally, Oumuamua forced humanity to confront the unpredictable nature of space exploration. Unlike missions designed for fixed targets, interstellar visitors are transient, arriving without warning and departing forever. Their study requires flexibility, speed, and ingenuity. Oumuamua had arrived unannounced, revealing the universe's capacity to surprise, challenge, and inspire those who dare to look beyond our solar neighborhood. In the end, the object was both a scientific puzzle and a call to action. Its discovery underscored the need for better technology, faster response systems, and innovative thinking if humanity hopes to study interstellar phenomena directly. Oumuamua was more than an object. It was a message. The universe is in motion, and we must adapt to understand it. Seen lessons for future encounters. Oumuamua left humanity with a set of urgent and profound lessons. It demonstrated that interstellar objects are not merely theoretical, they are real, observable, and capable of entering the solar system with minimal warning. Their detection depends on vigilance, speed, and coordinated effort across global observatories. First, observation infrastructure matters. Oumuamua was discovered by Pan-SDARS-1, a survey designed to scan the sky systematically. Its detection highlighted the importance of continuous wide-field monitoring. Future discoveries will rely on even more sensitive instruments, capable of detecting faint, fast-moving objects long before they pass through the inner solar system. Second, speed and timing are critical. Oumuamua's brief visit left astronomers with only weeks to gather data. Rapid response systems, both for telescopic observation and for potential space missions, are essential. Humanity may need spacecraft that can accelerate quickly, instruments that can collect maximum information in minimal time, and AI-driven decision systems to optimize observations during fleeting windows. Third, flexibility in interpretation is necessary. Oumuamua defied classification, forcing scientists to consider hypotheses ranging from conventional cometary physics to more exotic possibilities. Future interstellar objects may be equally surprising. Maintaining an open, evidence-based approach ensures that extraordinary discoveries are not dismissed prematurely. Fourth, collaboration is key. Observatories, research teams, and space agencies across the globe work together to study Oumuamua. Its rapid departure highlighted that no single nation or organization can fully capture such fleeting phenomena alone. International coordination and data sharing are critical for maximizing scientific yield. Finally, Oumuamua offered a glimpse of the galaxy's hidden dynamism. Its extreme elongation, tumbling rotation, and subtle acceleration were reminders that the universe is full of phenomena beyond our experience. Each interstellar object could carry information about distant star systems, planetary formation, and cosmic history. By studying these messengers, humanity can expand its knowledge of the cosmos and refine the technologies needed to explore it. In the end, Oumuamua's visit was brief but transformative. It left unanswered questions, sparked debate, and inspired technological innovation. It showed humanity the importance of readiness, imagination, and scientific rigor when facing the unknown. Most importantly, it reminded us that the universe is not distant and abstract. It is active, unpredictable, and capable of delivering visitors that challenge everything we thought we knew. Oumuamua's legacy is enduring, a call to watch the skies, to think boldly, and to prepare for the next interstellar messenger. Scene 19, A Visitor Remembered. Long after Oumuamua vanished from sight, its presence lingered in the minds of astronomers and the public alike. It had passed through the solar system in silence, leaving no debris, no tail, no trace except the data captured in telescopes' sensors. Yet the impact of its visit was profound. For the first time, humanity had observed an object from another star system, a visitor that reminded us how small and fleeting our perspective can be. The object's brief appearance sparked global fascination. News outlets, documentaries, and social media circulated images and models of its elongated, tumbling form. People marveled at the idea of matter traveling light years through the void, carrying information about a distant system. The name Oumuamua, scout or messenger, captured the imagination perfectly, emphasizing the fleeting yet significant nature of its arrival. Scientific circles, Oumuamua became a benchmark. Its discovery prompted researchers to reassess the assumptions underlying asteroid and comet studies. If one interstellar object could pass through undetected until modern surveys, how many others had likely gone unnoticed? This realization led to renewed investment in wide-field sky surveys, automated detection systems, and rapid response protocols to capture data on future interstellar visitors before they fade into the void. The visitor's legacy was not only scientific, it symbolized the first tangible connection between humanity and the wider galaxy, a reminder that we are not isolated in our cosmic neighborhood. For educators, Oumuamua became a story that inspired students to pursue astronomy, physics, and engineering. For the public, it embodied wonder and curiosity, a tangible proof that the universe is dynamic, surprising, and full of unknowns. Oumuamua's influence extended into cultural imagination as well. It appeared in literature, films, and artwork, often depicted as a silent traveler carrying messages from distant stars. It became an icon of exploration, curiosity, and the enduring human desire to understand the cosmos. Even as telescopes continued to track more conventional objects, Oumuamua remained the symbol of humanity's first interstellar encounter, a fleeting visitor whose story would inspire decades of discovery. In this way, Oumuamua's memory became a bridge between science and society. It highlighted the fragility of opportunity, the fact that we had only weeks to observe it, and the excitement of discovery, showing what is possible when humanity looks to the stars with curiosity and rigor. Its passage may have lasted only months, but its legacy would endure for generations. Scene 20, Inspiration for the Next Generation. Oumuamua's visit inspired a wave of curiosity among students, amateur astronomers, and future scientists. Classrooms discussed the interstellar visitor as an example of how the universe continually challenges assumptions. Teachers highlighted the object's unique characteristics, its extreme elongation, tumbling motion, and subtle acceleration as a gateway to understanding orbital mechanics, light curves, and observational astronomy. Universities and research programs incorporated Oumuamua into curricula, using it as a case study in interstellar detection and planetary science. Students simulated its trajectory, modeled its tumbling motion, and debated hypotheses for its mysterious acceleration. The object became a hands-on tool for teaching scientific methodology, how to observe carefully, analyze rigorously, and remain open to unexpected outcomes. Amateur astronomers, too, found motivation in Oumuamua. The discovery underscored that even small telescopes, when coordinated and applied with care, could contribute to global knowledge. Online forums and citizen science initiatives proliferated, with enthusiasts sharing observations, modeling data, and learning from professionals. The interstellar visitor had democratized curiosity, showing that discovery is accessible to anyone willing to study the sky. Beyond academics, Oumuamua inspired a philosophical reflection on humanity's place in the cosmos. Its journey highlighted that the galaxy is not static. Objects move between star systems, carrying the history of distant worlds. This perspective fueled discussions on interstellar exploration, the potential for future encounters, and the need for technologies that can reach beyond our solar system. Space agencies also drew lessons from Oumuamua. Concepts for rapid-response spacecraft capable of intercepting interstellar visitors gained traction. Mission planners considered new propulsion systems, autonomous navigation, and adaptive instruments. Oumuamua had revealed both a scientific opportunity and a technological challenge, motivating innovation in ways that conventional solar system objects could not. In every sense, Oumuamua became a catalyst for curiosity and ambition. It challenged generations to think beyond conventional boundaries, to prepare for the unexpected, and to embrace the universe's vastness with wonder and rigor. Its fleeting passage was a lesson in humility, creativity, and the pursuit of knowledge. Humanity had witnessed a visitor from the stars, and in doing so, had glimpsed the limitless potential for discovery in the galaxy. Redefining cosmic expectations. Oumuamua reshaped how scientists conceive of the solar system and interstellar space. Before its arrival, most models treated the solar system as largely self-contained, with only a few exceptions for comets from the distant Oort cloud. Oumuamua shattered this assumption, proving that interstellar visitors can traverse the solar system unseen, highlighting a dynamic, interconnected galaxy. Its extreme properties, elongation, tumbling, and unexplained acceleration forced astronomers to reconsider classification schemes. Oumuamua was neither asteroid nor comet in the traditional sense. Its detection underscored that natural phenomena are broader and more diverse than previously documented. Any future interstellar visitor might be equally anomalous, prompting researchers to expand observational strategies and theoretical frameworks. This realization also affected planetary defense strategies. While Oumuamua posed no threat, its rapid hyperbolic trajectory highlighted the need to detect fast-moving objects early. Understanding interstellar visitors is not only a matter of curiosity, it can inform planetary protection measures, tracking, and response planning. Science and safety were intertwined, reminding humanity that exploration comes with responsibility. Oumuamua also inspired a paradigm shift in how humans think about exploration. The concept of messenger objects traveling between star systems introduced a new frontier in astronomy. Each such object may carry information about its origin, acting as a natural probe from another system. Detecting, analyzing, and eventually intercepting these messengers could become a routine aspect of interstellar study, transforming humanity's approach to the galaxy. Furthermore, the discovery encouraged innovation in observation technology. Automated, wide-field surveys, high-speed data processing, and rapid response coordination became priorities. Oumuamua demonstrated that the universe does not wait for readiness. It passes by, fleeting and unpredictable, and science must adapt to seize opportunities. In essence, Oumuamua redefined expectations for what humanity might encounter in the cosmos. It emphasized unpredictability, diversity, and the need for adaptive thinking. By arriving unannounced, revealing the unexpected, and departing silently, it challenged astronomers to expand their models, rethink their assumptions, and embrace the complexity of interstellar space. Scene 22, a legacy written in the stars. Oumuamua's story, brief though it was, became a milestone in human understanding of the galaxy. It demonstrated that interstellar objects are not theoretical curiosities, they are real, detectable, and capable of carrying information across light years. Its visit left humanity with a lasting legacy of scientific insight, curiosity, and ambition. The object's data continue to be analyzed, forming the foundation for models of interstellar travel, formation of exotic objects, and the physics of hyperbolic trajectories. Its influence extends beyond research papers. It informs public imagination, educational programs, and the philosophy of exploration. Oumuamua reminds us that the universe is alive with motion, diversity, and mystery. Future discoveries of interstellar objects will build upon the lessons it left. Detection techniques, observation protocols, and rapid response missions are now being designed with Oumuamua in mind. Every telescope scan, every survey, carries the potential to capture the next interstellar messenger, offering glimpses into planetary systems beyond our own. Beyond technology and research, Oumuamua's legacy is symbolic. It represents humanity's first encounter with matter from another star system, a reminder that the galaxy is interconnected and that objects move silently between stars. Its name, Messenger, captures the essence of its significance. For a fleeting moment, it visited our neighborhood of space, inspiring awe, debate, and the pursuit of knowledge. Culturally, the object will remain iconic. Artists, writers, filmmakers, and educators continue to reference its journey, ensuring that Oumuamua's story is embedded in human imagination. It exemplifies the thrill of discovery, the beauty of the unknown, and the humility required when confronting the cosmos. Ultimately, Oumuamua's legacy is a call to watch, learn, and prepare. It teaches that the universe will continue to send visitors unexpected and extraordinary, and that humanity must be ready to observe, interpret, and understand. Its brief journey through the solar system may have lasted only months, but the inspiration, knowledge, and curiosity it generated will endure for generations. In the vastness of space, Oumuamua remains a silent traveler, but its impact on Earth, scientific, cultural, and philosophical, is permanent. It has written its legacy in the stars, reminding humanity that the cosmos is dynamic, mysterious, and full of stories waiting to be discovered. If you were fascinated by Oumuamua's journey, don't forget to like this video, share it with your friends, and subscribe for more mind-blowing stories from the universe. Hit the notification bell so you won't miss the next interstellar adventure.